guys, and welcome to the last lesson of Unit 3, Lesson 3.9, Solving Trig Equations, this time in radians. So for our first example, we're basically going to tackle each one of these examples the same way we did yesterday. So in this example here, we have 6 sine x minus cosecant x equals 3. So our job is to probably change this cosecant in terms of sine. So we'll start off by doing that. So 6 sine x minus, now cosecant is really just the reciprocal of sine, so 1 over sine x, and then equals 3. Now the problem that we're faced with here is that now we have a fraction, and even worse, sine x is in the denominator. So let's go ahead and get that out of the denominator, and the way we do that is basically you multiply each one of these terms by sine x. What results from doing that is we're left with 6 and then a sine squared x minus, well, if you have 1 times sine x over sine x is crossed out, we're left with 1 equals 3 sine x. Now if you remember from yesterday's lesson, you can clearly see that we're working with some sort of quadratic equation here because of the sine squared. So when you're working with quadratics, move everything to one side so that way the other side equals 0, and then we can go ahead and factor if possible. And if you really want to, you can do the substitution. Let some variable equal sine x, so that way it looks a little more like trinomials that you're used to working with. Okay, so we have a complex trinomial here. We want to try and find two numbers that multiply to -6 and add to +3. But unfortunately, those two numbers do not exist, so this is not factorable. And whenever that is the case, we have to use the quadratic formula. Okay, so let's go ahead and do that. We want to solve for a here. So this time a equals -b plus or minus b squared minus 4 times a, the a value here, so 4 times 6 times -1. So that'll give us positive 24 all over 2 times a, so 12. And if we go ahead and simplify this a little bit more, we're left with 3 plus or minus the square root of 33 over 12. Now essentially this ends up being two possible answers. You get either a equaling the positive, so 3 plus root 33, or 3 minus root 33. Well, in both of these cases, these are not nice numbers, not nice decimals. So let's try and round to the nearest hundredth here, because that's what the question does tell us to do, round to the nearest hundredth. So in the first one, we get a possible value for our variable here as 0.73, and the other one to be -0.23. Okay, but again, a was never part of the equation. We use that to substitute. So really what we're left with is sine x is 0.73 or sine x equals -0.23. Now ideally when you're faced with a question like this, it would be awesome if this ratio here belonged to the special triangle family, and clearly it doesn't. So we'll start it off the same way. So we want to know which quadrants sine is positive in, because it's positive 0.73. So the first quadrant and the second quadrant. Now we need to figure out what that related acute angle is. So we'll call it theta related. Okay, now the way that we get that is, well, we're going to have to do sine inverse to figure out what that angle is. So sine inverse of 0.73 If you do that on your calculator, the related acute angle should give you 0.82. Now, one thing to point out here is that if you take a look at the top of the question here, we are given this domain between 0 and 2 pi. So right away, that tells me my calculator should be set in radians. So when you're going ahead and you are working out the sine inverse, your calculator should be set in radians, and so what we get here is 0.82 radians. That is our related acute angle, so 0.82 in there as well as over here. Now, as always, we need to find out those two angles. So this angle here. So our first possibility is we start at the standard position and you rotate counterclockwise. So our first possible answer is clearly from our diagram here is 0.82. The second angle, same idea, start in standard position, rotate counterclockwise until you hit the next terminal arm. So x2 almost went pi radians, so half or a semicircle. But we stopped 0.82 radians before that. So let's take our pi and subtract 0.82. And when you do that, you should end up with 2.32 radians. Okay, so we have two possible values so far for our angle x here. Now we need to work on other possible angles. So we'll take a look at the second equation that we kind of came up with here. And again, we need to find the related acute angle. So I'll start off by drawing my quadrants. This time it says sine x is negative 0.23. So where is sine negative? Well, it's negative here and here. So in the third and fourth quadrant this time. And in order to find the related acute angle, we're going to do sine inverse this time, but it's always a good idea to kind of ignore the negative sign here and always do the sine inverse of whatever the positive is. And the reason that we're ignoring the negative is because we just want to know what the related acute angle is. We kind of took care of the negative part by actually drawing the lines in the quadrants where sine is negative. Okay, so sine inverse of positive 0.23 gives you 0.23 radians. So that tells me that in both of these angles here, we have 0.23. Now I need to find the actual values for our x, our angle. So start in standard position, rotate counterclockwise. When you rotate counterclockwise, we go past pi and then add 0.23 radians to it. So I'm going to call this x3 because it's the third angle that we're finding here. Pi plus 0.23 radians. So x3 is equal to 3.37. And then again, start in standard position, rotate counterclockwise. So our last possible value here, we almost went full circle, so we almost went 2 pi, but we stopped 0.23 radians before that, so we're left with 6.05 radians. Okay, so 4 possible values here that will make the above statement true. So if you want to make a quick therefore statement, and that's it. Okay, moving on to the next example. Again, I take a look at the domain and it says between 0 and 2 pi. So I know I'm working in radians here. And I'm given this equation here. 8 times cos cubed of x minus 4 cos of x equals 0. The first thing you should always check for is common factor. So I have two terms here, and in both terms a 4 is common as well as a cos is common. So I'll factor that out and I'm left with 2 cos squared and then minus 1. Okay, And imagine these were questions that we're working with in the last couple of units. Basically, you want to take each thing and you want to set it equal to 0. So imagine 4 cos as its own bracket. If I set that equal to 0, I know that just cos x equals 0. If I set that bracket equal to 0, well, I have cos squared x is equal to, move the 1 over, and then divide by 2. So cos squared is equal to 1/2. But you want to isolate cos. So take the square root of both sides. So two things when you're taking the square root. Remember that you should always write a plus minus because both answers are valid. And especially when you're taking the square root of a fraction, well, what you're really doing is you're taking the square root of the numerator, which is just 1, and you're taking the square root of the denominator. Okay, so we have two possible values here, or two possible equations to solve for. We have cos x equals 0, and we have cos x equals plus or minus the square root of 1 over root 2. Okay. Okay, so in this question, we have a cubic function. So 2 cos cubed minus 9 cos squared minus 6 cos plus 5 all equals 0. So the first step is done. It already equals 0. If you like, you can do the substitution, let some variable this time equal cos x, so that it looks a little more familiar. Not entirely necessary if you're comfortable doing it the other way, just leaving the coses. But essentially, you're left with an equation that looks like this. When you're trying to factor this, well, you would try to do factor by grouping, but you see that none of the groupings would work out. So unfortunately, what we're going to have to use this time is, alright, so first we'll need to find a test root that'll work, that will make this equation equal 0. So if we call this our f of x, and we tried f at -1, you'll notice that it does indeed equal 0. So remember from last unit that a plus 1 is a factor. And then we go ahead and do synthetic division, knowing that -1 is a root. So our coefficients 2, -9, -6, and 5, we will drop down the first term, multiply, add them up, multiply, add them up, multiply, add them up. So confirmation that I did a good job, I get a remainder of 0. So essentially our function can be split up into, now we need to take a look at this question or this factor here and see if it's further factorable. So you want to try and find two numbers that multiply to 10 and add to -11. So those two numbers are just -10 and -1. So if we do decomposition, because this is a complex trinomial, well, this a plus 1 kind of goes along for the ride, and then what we're left with is 2a squared minus the 10a minus 1a plus 5. Now we can do factor by grouping inside these square brackets. So if I look at the first group here, I can factor out a 2a, leaving me with a minus 5, and in my second group I can factor out a negative 1, leaving me with again a minus 5. So again, keep in mind that you can't go on unless these brackets are identical. So what will happen now is we'll factor out the a minus 5, and that means we're left with 2a minus 1. So now that we're fully factored, we can kind of state our roots. Okay, so we know that a equals negative 1, a equals 5, and a equals positive 1/2. Now again, a was never part of the question. We just use it as a placeholder. So let's replace. Cos x actually equals negative 1. Cos x equals 5. And finally, cos x equals 1/2. Okay, so 3 things to find angles for. Now, for our final example today, this kind of showed up in, I think, 3.7's lesson. So we're just going to kind of go over it now. Also applicable, good application problem. So it says the height h in meters of the tide in a small port t hours after midnight is given by this equation here. So it's asking us what is the depth of the water at high tide and at low tide. So basically, all it's asking us for is maximum and minimum. Okay, well, because we have an equation already given to us, it's very easy to calculate the max and the min. Remember that max is just c plus a, so the midline plus your amplitude. In our formula, there's our midline, there's our amplitude, add them up. So 7.8 plus 3.5 gives us 11.3 meters. So at high tide, the water is at 11.3 meters, and at low tide, we calculate C minus A, which is 4.3 meters. Okay, next question says, what is the average depth of tide in the port? So what they're referring to here is, or what is the midline? Well, that's given to us exactly in the question. It's just our value of C, 7.8. Then finally, we want to find the height of the tide at 8 a.m. to the nearest tenth of a meter. Okay, so I'll take the question, or I'll take the equation from above, I'll rewrite it. Now, one thing that I do want to point out, and I often see this as a mistake on tests, is that this entire thing is the argument of sine. So a lot of people just calculate sine of pi by 6 separately and then multiply it by whatever this bracket is. That's incorrect. This entire thing is the argument of sine, so you're going to have to calculate sine of whatever's inside these red square brackets. Okay. So the question says find the tide at 8 a.m. The equation is given to us as time after midnight, so 8 a.m. is 8 hours after midnight. So we're really just trying to find h at 8. So wherever we see a t, we'll fill in with an 8. And we'll just simplify inside the bracket here. So sine pi by 6 times 5, so really 5 pi by 6 plus 7.8. And then at this point, you can do one of two things. You can recognize that 5 pi by 6, you can calculate doing special triangles on the graph, or because it's an application problem, you can just do calculator work. So type exactly what you see here, 3.5, hit your sign button, open up the brackets, and do 5 pi divided by 6, close the brackets, and add 7.8. And you should end up with 9.55 meters, but the question does say to the nearest tenth of a meter, so let's round to 9.6 meters. And now finally, at what times will it be high tide in the port over the course of one full day? So again, high tide refers to the maximum. So we really want to know when the height is equal to 11.3. Now remember, we calculated this maximum in part A of the question. So let's take our function, and we're going to set h equal to 11.3. So h equals 3.5 sine. So this looks very similar to questions that we were doing in lesson 3.7. So basically you want to isolate sine and its argument, because the thing that you're looking for, t, is inside that argument. So the first thing we'll do is move that 7.8 over, and then we want to divide both sides by the coefficient here, 3.5. So again, as we did in the other day's lesson, I want to know what angle of sine will give me a ratio of 1. So sine of what gives me 1? So if it's helpful, rewrite the question just for a second to look like this. And again, as I mentioned earlier, whenever you are trying to find sine or cos that equals 1, 0, or negative 1, take a look at its graph. So here's my rough sketch of sine. So clearly from the graph, the theta should be equal to pi by 2. Pi by 2 gives us a maximum of 1. So essentially, I should set my theta equal to pi by 2. So we'll go ahead and do that. Theta, our angle, should be pi by 2. So when this equals pi by 2, sine of it would give us 1. So now we just need to isolate t and solve. So basically I want to divide both sides here by pi by 6. Now remember, we can't divide fractions, so we need to flip in times. So pi by 2 times 6 over pi. Pi's cross out, and we're left with 2 over 6, or 6 over 2, which is just 3. And then finally, move this negative 3 to the other side, and that gives us a value of 6. So that tells us, that the first high tide happens at 6 a.m. If we wanted to find out, let's say over a course of a day, how many times or at what times we've reached high tide, we want to take a look at the period of the function for the other high tides. So I'm just going to rewrite our equation. The thing that we're interested in to help us find the period is our k value. Now remember that the period is equal to 2 pi over k. Well, since our k value is pi by 6, we need to flip and multiply. Pi's cross out. So that tells us that the period is every 12 hours. So if we wanted to know what other time during the day in a 24-hour period, well, if the first high tide happens at 6 a.m., 12 hours later is 6 p.m. Okay, so as a final therefore statement, a lot of the times you'll see in these questions that time is given in the 24-hour clock. So this would be 6 o'clock, and this would be 6 p.m. Alright, so that's it for today's lesson, and if you have any questions, make sure you ask in class. Take care, guys.